Hello, colleagues. My name is Joshua Olusegun Ajitomobi. I want to thank you for your interest in this training. Let us not forget the training is focusing on how to estimate technical efficiency with the use of R software. The starting point is to set our working directory. To set our working directory, we come to session here, set working directory, choose directory. My directory is a folder on my desktop which I named training, TE training, TE training, TE training. I open it. That is how to set the directory. We know we can estimate our technical efficiency using stochastic frontier analysis. So this video I'm sharing now is focusing on stochastic frontier analysis. I will still share the second one on DEA. So when working with stochastic frontier analysis, we can make use of cross-sectional data, panel data. Now I want to start with making use of cross-section data. And let us come here, see files. I want to show us the data that we are going to make use of. This is the data, fdat.csv. We can see details of the data here. Let's come to our folder so that we have a glimpse of the content. This is the data set, fdat. So the data was collected by World Bank and covered enterprises in Nigeria. So from the WBE, I extracted data on small and medium firms, and that is what we want to use. It covers 825 small and medium enterprises in the country. So this is the content of the data. The respondents, that is the number of observations we have, is 825. Then we have size type, small and medium, that is the type of enterprise, city covered, the industries, sales in naira, labor in number of people employed, the cost of materials, then capital. So let's close this and let us return to our R here. So let us import the data sets. To import the data sets, you click here, import data sets. So it's retrieving the data. I want the data to be named fdat. I don't want this underscore. So I import it. So this is the data set. So let's go back to our script file. We're going to make use of some packages in R. One is Frontier package, the other one is DAR, and summary tools. But for now, we're not actually using the DAR. So our interest is Frontier package and summary tools package. If you don't have the packages, if you type library Frontier, it's going to tell you there is no package called Frontier. So let's say you don't have it, then you come here, tools, install.packages. Then you will type the name of the package here. Like if for instance, if I don't have Frontier, I will type Frontier. You see Frontier. So and I pick it here. Though I'm not going to install it because I already have it. So let me cancel this. But I just show you how to install the package. And you will need internet for the installation. And installation is always once. The moment you have done it, is there. So the moment you have done it, it's going to store it in the Windows library. And that is the reason why we normally type library here. So let me load the packages. So anytime you see this red sign, you have to wait and allow R to finish whatever it's doing. So now we have installed all the packages. The starting point of any research is to tell us something about the data set you are using. So we want to quickly look at the descriptive statistics. I call it start_fdat. That is the name. You can give it any name of your choice. And the command is with fdat, comma, DSCR is the function. Fdat is our data set. Start equals common because I want just common statistics. Let me cancel this transpose. There is no need for transpose. But if you want the result to be transposed, then you put it there. Then I want to view the results in my working directory. That is why I say summary tools dot view. The reason why we put summary tools here and not just view is that view as a command may be in other packages apart from summary tools. So this is saying view in summary tools. Then start_fdat, which is what I've generated here. Then I give it a name, start_fdat. This is the name that will appear on my folder. So let us run it and check our working directory for the results. Good. So let's go back to our working directory. So this is it here. So say let us open it. Say open with. So open it with Microsoft Word. So here is our results. Let us design the table. So here we are. Number of observations 825. The mean, the standard deviation, the minimum, the median, the maximum, and so on. And immediately you have it here, definitely you can delete whatever you don't need. So let's come back to our R. So now we've done the descriptive statistics. Um, we want to run a Cobb-Douglas stochastic production frontier for a start. And in this case, um, we call this one error components model, because we are not including the inefficiency variables. So to do that, I call it SFA-PF. The function is SFA. My dependent variable is log of sales as a function of log of labor. Let us not forget that in Cobb-Douglas, the dependent and the independent variables are always introduced in log forms. So I have log sales as a function of log labor plus log of capital plus log of material. Then this is my data, which is f dot. So if I've done that, to get my result out, I said summary. This is SFAPF that I've just estimated. Then extra parameter is extra par, so that I can have my sigma u, sigma v, gamma val, and several other parameters to explain whether inefficiency or error terms matters. So let's run this. So here we are. Our mean efficiency is 0.74. We have 825 observations. So let's now come here. Yeah. Usually, by way of interpretation, we know that these coefficients are direct elasticities, because that is the advantage of using Cobb-Douglas function. So the elasticity of labor is 0.82, that of capital is 0.02, that of material is 0.28, and these stars indicates their levels of significance. To be sure whether uh, inefficiency and error terms matters, then you check for the value of gamma, and the proportion of the error term that is explained, of the variation, sorry, the variation is either explained by the error term or by the inefficiency terms. So the proportion of the variation explained by the inefficiency is what is called gamma var. So, which means in our own situation now, the proportion of the variations in our dependent variable, in that case, we are using sales. So the variation in our sales explained by the inefficiency is 0.33. Then we need to maybe carry out likelihood likelihood ratio tests to compare the model with intercept alone with models containing the independent variables. So let's run it. Yeah. So this is to justify our error components frontier. Um, the null hypothesis is no inefficiency, in which case we resort to OLS estimation. But if we reject this, then we stick to our error component frontier model. And our interest is this um, p-value. I mean the significance of the p-value. So we can see 0.008. So which is even at 1%, it is statistically um, significant. So in that wise, we can reject the null hypothesis of no inefficiency, in which case we have some level of confidence to explain the result of our error component frontier model. So the moment we are sure of that, so that we are not resorting to OLS estimation, so we don't need to extract the coefficient of the OLS. Now, to calculate the efficiency for individual respondents, so which in our own case, we are going to have 825 efficiency scores. So to do that, I say f that $f because I call it f and I want that f to be in our f that. So I say frontier dot efficiencies, so that I want the efficiencies function in frontier and not in anything else. So SFAPF that we have estimated. So if we have done it correctly, then you run. Yeah. So, and you can check the results. Let's check the result for the first 6 observation. Add f that dollar EFF. So for the 6 observations, these are the efficiency scores. And for the last is tail, so that we are not this f that dollar EFF. So let's check. Yeah, you can see for the last 6 observations. So at least we are sure that all the 825 observations have efficiency scores. But what if we want to estimate efficiency effects? What we've just done is error components model or error component frontier. We have not considered factors that may influence inefficiency. So if you want to do that, you know there are 2 methods. One is after estimating the technical efficiency, you can extract it and then run it against the inefficiency variables. That is 2-stage. But if you want to make use of 1 stage, which is actually better because some of the inefficiency variables also may influence some of those independent variables that you have. So in order to control for such econometric problems, um, we use maximum likelihood estimates, um, making use of one stage procedure, in which case we include the inefficiency variables also in the model directly. So, and that is Coeli approach that we want to use here. So if that is what we want to do, then we have we define the direct inputs, sales, log, sales, labor, capital, material. Then here you will now have this perpendicular sign, and here you will now include um, the variables that might influence your efficiency. In this case, we're just considering size type. You can have as many as possible. So, and again, data equals to that. Every other thing now is like what we've done before. So if we want to estimate this, let us do it again and look at the results. Yeah, we can now see that there is an increase in the mean efficiency. Previously, it was 0.74. It's now 0.85. So, and again, we may want to do the LR tests. Yeah. So the LR test also shows that we should retain our efficiency effect frontier and not revert to OLS estimation. And in order to obtain the efficiency scores, here we have F that dollar. I call that one F1. Then frontier efficiency, this run. Then here I want to generate, I want to write my F that data set containing the efficiency scores. So if that data set with all the efficiency scores, I say write.csv, left that, then this is my working directory here. And I give it a name, f.te.csv. So let's run this and check. So let's go back to our working directory, and this is it here. So let's open it. Yeah. So now here we have the efficiency scores for all the firms, 825 of them. You see, this is the error component model. That is the model without the inefficiency variables. But when we include the inefficiency variables, which is the efficiency effect frontier, so we have these scores. So I hope it's a bit clear. So please let us go over it and re-estimate it ourselves. I think I've sent the data set also to us. Yeah. Now, the second aspect of the stochastic frontier analysis is to consider a situation whereby we have panel data. We will need an extra package This is PLM, that is a panel linear model, PLM. So if you don't have it, then make sure you install it. And we're going to use rice prod, that is a data set on rice production in Philippines. And the data set also can be found in Frontier package. Yeah. So to load the data set directly, you can just say data rice. You can see it here. So you know it's in Frontier package. So you click on this, so you run it. Yeah, fine. So the moment you have it, then you can continue to make use of it. Because if you don't have it, you can't use it. Um, but to see the content, let me show us the data set here, this rice plot field, so that if you want to work with panel data, or you want to collect such data, or maybe to input such data in your spreadsheet, then you will know what to do. So this is representing the year. We have 8 years. So in the first year, this is the farmer's code for the three of them. So this will run from 1 to 8. So 1, 1, 1, 1, 1, 1. Then you will have 1 to 43 years. Then you will now have 2, 2, 2, 2, 2, 2, 2, 1 to 43 up to 88. So that is the way to address that one, because we are dealing with panel. Uh, and this could actually be actual year anyway. You can say year, maybe 2000, 2001, 2000. If it's 2000 to 2007, for instance, one will be 2000, 2000, 2000, 2000, and so on. So it's good that we understand it. So these are different direct input, production. This is our production. That should be the dependent variable. See area, labor, NPK fertilizer, other inputs, price, this and so on and so forth. So, and these are prices: price for fertilizer, price for labor. That is in case you want to estimate cost frontier. But we are not dealing with cost frontier for now. So, and this age, education, household size, and so on. In case you want to account for determinant of the inefficiency. So let's close this and go back to our R. So the starting point is to define the panel. So to define the panel, I call it rice plot field equals p data dot frame, that is panel data frame. This is my object. To define it, I need two things. I need the ID for the number of the farmers. This is the cross-section aspects. Then the year covered. We need these two to define the panel data. So then after that, like before, we need to do some descriptive statistics. And let us not forget that we are now dealing with panel data. So I'm introducing to us a package in R that does it better. This expander. Then we need tidyverse. Then we need cable extra. Tidyverse is to help us in our data manipulation. Then cable extra is to help us to export the results in HTML form, in a very readable form, actually. So let's run up to the libraries that we need. Then I explain further the next thing to do. So we have here run. Okay. So um yes, now we are dealing with a complete data without any missing observations. But most of the time when you are working with microdata, particularly those collected by World Bank or collected by our national statistics and so on, you cannot escape having missing values. So you must first know how to deal with the missing values. We are not doing that, but at least you must know whether missing values exist or not so that you deal with them. Maybe some other time we may look at how to handle some of these missing values, which is very straightforward to do. So let us, here we say prepare and underscore missing values. The moment you are typing is going to come up. So run. Yeah. So here we are. So let me zoom it so that we can see it clearly. Yeah. So this is showing us that we don't have any missing value. If we have missing value, it's going to show us in different colors. Yeah. So we don't have any missing values. So the next thing we try to do is to prepare our descriptive statistics, which is very straightforward. We said I call it disk rise, that is describe rise. Then prepare underscore descriptive value. Then the name of um, the data sets. Sorry, we have to continue from there. I think maybe I have to do another video because